So, here is an example to motivate the language for the experiments. There is a manufacturing process in which air bubbles are identified. I am trying to build a product using some manufacturing process. In the course of the process, there are some air bubbles that are created. As a result, the product is rejected. Hoping to determine in an experimental sense how to fix this problem, some engineers were recruited and they identified the reasons for the failure. The reason for the failure is a bubble, but they identified the causes. What were the causes? The two types of resins and three types of prepolymers that were used. The three amounts of prepolymers, it is 100, 200 and 300 grams. Now, here are few questions. How would you measure the performance? I think we are losing the thread here. Okay. This is in continuation to the previous slide where we talked about factors, levels and response. Here is an example. I am manufacturing a product, but there are air bubbles inside the product, as a result of which the product is being rejected. I want to minimize the rejection. In order to do that, I want to understand the reasons behind the air bubble. I understand the reasons that contribute to the air bubbles are your resins and the amounts of prepolymer. Now, my question is, what are my response? What is my response that is need to be measured? What is my objective in the problem? To remove or to reduce the air bubble. To either remove or reduce my air bubble. So, that objective is what your response is. Response is a quantity of interest. If you see here, response is what the quantity of interest is. So, what is your quantity of interest? For the first question, what is your quantity of interest? Is it the amount of air bubble?
The presence of an air bubble.
Okay. So, if is one air bubble better than 10 air bubbles?
No.
Why? So, it is not only the number, but it could be the size. There could be 10 tiny air bubbles and there could be one big air bubble. So, it does not mean that 10 is bad than 1, sorry 1 is better than 10. So, we can use the word density. So, that is my quantity of interest. So, the performance is measured by measuring the number of air bubbles. What is the quality characteristic? Smaller the better. Do not say L type lower the better, L stands for larger, S type smaller the better. What are the factors to be identified and what are their levels? What is your factor 1? Is the factor, first factor. What are the levels?
Resin 1, resin 2.
There are two resins, resin A, resin B, resin 1, resin 2, whatever. What is the second factor? What are its levels? Okay. We are not going to solve this problem. This is only to get you introduced to the language of the experiments. The result can be measured by counting the number of bubbles, no units, or size of the bubbles together. Quality characteristic is smaller the better. Factor 1 is the resin, 2 levels types 1 and 2, F2 is the prepolymer, 3 levels, that is 100, 200 and 300 grams. So, you can actually take a look at this problem itself. You want to understand how this resin and the pre-polymer interact. That is what is going to give you the quantity of interest, which is the air bubble. So, how can you go about doing it?
For each region, we have to take a sample from the polymer and we have to mix the composition.
So, what he is doing is, what he is saying is, I will fix the resin 1 and I will change the pre-polymers 100, I will check out how many number of bubbles, 200 how many number of bubbles, 300 how many number of bubbles. How many experiments you have done? 3 experiments you have done. Then what you will do? You will change the resin from resin 1 to resin 2 and you will do 3 different experiments. 6 experiments you will do and you will know which resin and what polymer have this combination, correct. This works nice for 2 dimensions. Now, let us bring a third dimension into this, some kind of adhesive material, I am just saying. So, resin, pre-polymer, adhesive. You fix resin, pre-polymer 3 times and let us say the adhesive also can have 3 levels. You understand what I am saying? So, you will have a resin, you will have 3 pre-polymer combinations. Then for each of this pre-polymer I will have an adhesive, like this I will have for other 3, I will have for this guy, correct. And then I will also repeat this R1 to 2. Is that all? But you can look at the number of experiments, what has happened. Initially in this case it is only 6, but now it is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 2 is 18. Let us imagine that this was a product design combination. You have to build 18 proof of concepts to make a decision. Sorry?
We can do a finite number of tests with the different combinations and try and develop a control product.
That is the point, that is the point. Okay. But sometimes you might not be able to do that. How can you do in a statistical sense is what the question is. I just want you to appreciate, and these numbers will go in an exponential fashion. We will see. So, what he just pointed out and we just discussed right now is investigating one factor at a time. We fixed one factor and then we are seeing the effects. Okay. It is quick, there are no complex formulas, you just need to conduct the experiments. For one factor, the levels are changed while the other factors are frozen, correct. You see here in this particular example, I fixed R, I fixed P1 to understand what is the effect of A, and then I figured out A2 is a good combination. My experiment cannot stop there, because I could get a better combination with P2 and R1 or with P3 and R1 and some other combinations of A, or this entire thing with respect to R2 also could give me a better result. So, that is where the problem is. For one factor, the levels are changed while rest of the factors are frozen. You have to do at least 2 experiments at 2 different levels, correct. If you have 2 levels, you have to do 2 experiments, level 1, level 2, you have to do that. You are not conducting, please understand there is a difference, you are not conducting 2 experiments at each level, you are conducting 1 experiment at each level and there will be 2 levels at least. So, you need to do 2 experiments. I hope you get it right, R1 and R2. Let us say that I fix something, I am coming in the opposite direction, A1, P1 I fix, I want to know the effect of R, then I have to do at least 2 experiments, R1 and R2. For the problem that we are talking about, the x axis here is the resin type. So, resin type 1, type 2 and this is the result. What is the result in our case?
The number of bubbles, density of bubbles.
Yes, it is the number of bubbles or the density of bubbles. So, it is 1, okay. This is basically for the level 1 and the level 2 that we are talking about, okay. Meaning for type 1, I have got 7 bubbles and for type 2 I have got 3 bubbles. So, which one is better? There is no 3, okay, 3 bubbles, which means this type 2 is a better option. Sample 1, the resin type 1, the result is 7 air bubbles and then for the resin type 2, the result is 3. What if you need to know the result for another type of resin? I changed my mind, someone came and told me actually there is one more resin in the market, but I want to know what will be the corresponding number of bubbles for that resin. Do I need to repeat an experiment or is there a easier way for me to understand what will be the number of bubbles?
The resin characteristics is somewhat similar to both of these two. We can infer some information from this.
Okay. So, if the resin characteristics are somewhat closer to the existing resins, basically I need to know something about the resins in terms of their composition, their ingredients, their performance, okay. Then I can make that kind of a conclusion. If I am able to correlate the resins themselves, then I can do an interpolation here, otherwise I cannot, that is all. To answer, the primary answer that he gave is correct, you will have to repeat the experiments, unless you have some correlation information between the resins. Since discrete, because this is considered as discrete, right. However, within the discrete, if I know the properties, then it is continuous. You can come up with an arbitrary property, you might not have a material, you can call it as a fictitious material. But if you consider it as discrete, let us say that you are an end user, you do not know any characteristic, you are just a user of the resin, then it is resin A, B and C or resin 1, 2 and 3, you do not know anything about it. It is a discrete stuff, so you need to conduct a additional experiment, you cannot interpolate. That is with the discrete factor. The next one that we are discussing is the pre-polymer with 3 levels. The pre-polymer was 100 grams, 200 grams, 100, 200 and 300 grams. For 100 grams the result was 2 air bubbles and for 300 grams the result was 6 air bubbles and for 200 grams the result was 4 air bubbles. Now I have a question, should I do or should I have done all the 3 experiments or I could have gotten away with 1 or 2 experiments?
Since we do not know what properties of the pre-polymer interact with the material resin, so we cannot actually identify if it's going to be, what kind of a relationship it's going to be between the resin and the pre-polymer and what is going to cause the bubble. So we need to conduct the experiment.
Yeah. What he is saying is, since we do not know the relationship between the resin and the pre-polymer, we might not be able to reduce the number of experiments. But let us say that you know the relationship, what can you do about it, or how will you go about it?
Then interpolating it is a better option.
You will basically try to interpolate. But from an interpolation perspective, you need to know whether it is a linear, it is non-linear, that is what he said. We may not know the relationship between your prepolymer and the resin. If we know that, we at least have a rough idea that it is linear, it is non-linear, then we can say, let us say that it was linear. Right now I have constructed, after the 3 tests we have kind of show that it is a linear relationship. But let us say for whatever reason you know a priori that it was a linear relationship, then you could have gotten away with just these 2 numbers. For the third one, I know you can interpolate from these 2 guys. So, for 100 grams it was 2 bubbles, and for 300 gram it was 6 bubbles, and you can, so you can interpolate for 200 grams it will be 4 bubbles. The result for the 200 grams can be interpolated, but what if the trend is not linear? The trend is not linear, or you were to believe that the trend is not linear, then you need at least 3 points, because at least quadratic, right, n minus 1, quadratic means second. So, you need at least 3 points. If you believe that it is highly nonlinear, then you would expect at least, you should have at least 4 points. That is what these 2 graphs are talking about. Okay. So, that is where the designer comes into picture. The designer should have an idea on whether it is a linear function, or it is likely to be quadratic, or nonlinear, highly nonlinear. What do we know until now with respect to design of experiments? We have not gone into design of experiments, just the experiments. Okay. Experiments on at least 2 levels are necessary. That is what we discussed, right? Level 1, level 2. At 2 levels are necessary to learn about a factor's behavior. For continuous factors, at least 3 levels when nonlinear behavior is suspected. If it is highly nonlinear, you need about 4 levels or 4 points. If you have no idea about the physics and time is a constraint, then you can go ahead with this 2 level experiments. You just need to know the bounds. And nonlinearity applies only when you have continuous variables. With discrete variables, anyway you need to go and calculate, does not matter how it varies, you are going to go and calculate at each of the levels. But there are slightly smarter ways of doing this stuff. Instead of fixing one factor at a time, you can also try to do several factors at a time. So, we will see how we go about that. Right now the way that we have looked at it is, you need to run at least n times 2, that is what we discussed here, right, number of experiments to understand the effect. But there is a slightly smarter way, you do not need to do 2n times, but you can get away with it with n plus 1 times. If you see what I am talking about is, I am talking about this one. I am talking about this one. You at least require 2 levels to understand R1, R2, P1, P2, A1, A2, at least 2 experiments you should have done. So, it is 2 times n, but you do not need to do that, you can still get away with n plus 1, that is what we are saying here. Of course, there are some, so there is a factor, the factor is, you have to read it this way, this is your factor. This is another example, the factors are A time, B temperature, C pressure, the respective units are here. Each factor has 2 levels, level 1, level 2, and here are the values, and I am using this notation. A1 means level 1 of factor A, A2 means level 2 of factor A, and I am giving you the values 4, 8, whatever it is. Now, how many experiments do I need to run? 2 experiments for each factor. How many factors I have? 3 factors. So, I will have to do 6 experiments. Do you agree? You have time, 2 temperatures and then 2 pressures. So, 2, then 4 for time it will be another 2. So, it is 6 experiments you will have to do. So, the deal is, we said that there might be a smarter way to do it, right. You do not need to do 2 times n, you do not need to do 6 experiments, you might still be able to do it with about 4 experiments. So, here is the way. This is your experiment, number of experiments 1, 2 and 3 and 4, and these are your factors A, B and C. This is your result. For each combination, for each experiment, what is my result? And I call my result as response. So, response 1, 2 and 3, 4, 4 experiments, 4 results. Now, look at the way that the experiments are conducted. Level 1 of A, level 1 of B, level 1 of C. Please note, fixing B2, B1, C1 and changing only A2, right. I am fixing B1 and B and C to B1 and C1 and I am changing only A. So, I kind of get the effect of A. Look at the third experiment. I revert back to A1 while C is still fixed at C1 and I change B from B1 to B2. So, now I can get the effect of B. So, is the case with respect to the final row, where I fix A and B to 1 and then I am getting I am changing C to C2. So, in the place of 6 experiments, I am doing only 4 experiments, but still I will be able to get the effect of A, B, C. How do I get the effect of A? For instance, if I am interested in the effect of A, I have to take these 2 guys, 45 minus 60 or 60 minus 45, that will be the effect. If I am worried about B, then I have to do this guy and this guy. That difference 45 minus 20 will give me the effect of B. Similarly, for C, I have to do 35 minus 45, that will give me the effect of C. Imran, is that clear? Okay. Remaining all factors is same, I am changing a particular factor so that I will give the effect of a factor. There is some limitation though in this. What is that?
Only considering 2 levels of each of the factors. The effect is linear.
No, one at a time. What is it? You are considering only?
Only considering 2 levels. What if there were 3 levels in each of the experiments? I could not be able to do.
No, that is okay. That we will come back. That is okay. In this particular course, we will look predominantly at 2 levels. It does not mean that you cannot do 3 levels. You can do 3 levels, but our discussions will be restricted to 2 levels. But even in 2 levels, there is a limitation in this. What is that? 1 factor? That is fine. As long as I get the information, how does it matter 1 factor at a time? What is it?
The factors are not linear.
What is the problem?
We add like in the graphs that you shown, like the curve is linear, we can go to a minimum experiment.
That is required only if you want to interpolate. We are not trying to do any interpolation, we are only trying to understand the effect of some factors. I have still not got all the information in this.
We don't know if the factors have an implicit relationship with the output or is it an explicit relationship.
That is not entirely true. If you have this data, input and output, you can construct that relationship. What I want you to observe, A changed from A1 to A2, while you fixed it at B1 C1, B1 C1. B changed from B1 to B2, while it was fixed at A1 C1. Can something else happen? For the effect purpose, yes, you need to change B1 to B2, C1 to C2, A1 to A2. What about the fixing?
It can be fixed at A2 itself.
You are fixing I could fix I could have started with A2, B2, C2. This experiment also will give me the effect of A, but this effect of A need not be the same effect of A, because the responses are likely to change. You understand? So, I am not factoring what happens if you go to the second level of the frozen variables. It might be entirely different. That is one limitation. The second is, this could also be an interaction. I could have a B1 C2, B2 C2 or B2 C1, whatever. That is also possible. Why should I always freeze them? Correct. Do you get the point? You can study that provided you have more experiments. Okay. So, this is certainly better than the previous one, but it still does not give you all the information. So, though all factors are considered, it is still one factor at a time. You are considering all the three factors together, but you are changing only one factor at a time while you are fixing the other factors. That is important. What if I fix the other two levels? Your results might change, which I cannot predict. There what you mentioned might play a role. If I know the explicit relationship, but that is the whole point. If you know the explicit relationship, you do not need to do the DoE, you can directly solve the problem. So, some little bit more examples with multiple factors. Most real life problems have greater than one factor that influence the result, and often there is an interaction, that is what I told you. So, we will see, rather than just hand waving as there is interaction, there are some examples here. So, someone has a headache. In order to take care of the headache, painkillers is given. The painkiller is supposed to suppress the headache for certain hours. That is what this problem is about. There are different types of painkillers: painkiller A, painkiller B. So, I can take either 0 painkiller of A, which means I am not taking A, or I can take one painkiller of A. Similarly, I can take no painkiller of B or one painkiller of B. If I am taking no painkiller, the pain is suppressed for 0 hours. If I am taking painkiller B, the pain is suppressed for 2 hours. If I am taking painkiller A alone, the pain is suppressed for 4 hours. If I am taking both of them, this A and this B, then the pain is suppressed for 6 hours, which is an addition of this and this. 4 plus 2 is 6. This is additive in nature. It is not necessarily always additive. So, this is one interaction. If I had them together, then they might actually add up. So, 0 of B, 0 of A, 0 hours suppressed. 1 of B, 0 of A, suppressed. Okay. Similarly, you can do. So, this is 1 comma 1 means they are both, and the number of hours it is suppressed is 6. In this case, A is 0, B is 1, suppression is 2 hours. So, in this case, B is 1, A is 0, so the suppression is 4 hours. So, the same data is presented in a graphical sense. Now, there can also be interaction plots. I mean, there is a synergetic. First is additive, just 2 plus 4 was 6. In this case, if you see 0 0 of course 0 hours. If one pill of A was taken 4 hours suppression, C, this is another pill. So, C suppression was 3 hours. If I took both of them together, it was 10 hours. It is not just 4 plus 3, it is much more than that. They are working really well. So, that means it is something like a composite. Okay. There is some positive relationship between them and hence they are suppressing. You can also have an anti-synergetic stuff. If you see here B, if I take B alone, it is suppressing for 2 hours, and if I am taking C alone, it is suppressing for 3 hours, but if I take both of them, it is still suppressing only for 3 hours, which means the effect of C overtakes the effect of B. So, that is anti-synergetic, meaning there is no use of having B. B is insensitive.